Well, hello friends. Welcome back to Code Review. Today we are going to look at a PR from Synac called Make Inode Watcher Very Gooder. And this is about watching the file system for changes. So we have a mechanism today in Serenity that allows you to ask the kernel to notify you when something in a directory changes or something about a specific file changes. So I think before we actually go and look at this, let me just give you some context on how it works today so that we can be familiar. So currently we have a system call called watch file, and user space can call this. And now we're in the kernel here. So user space can call into this and set up what we call an Inode Watcher. And an Inode Watcher is a file in the kernel, and it behaves like any other file. So when you create a watcher, you get a file descriptor back. And here's where we instantiate the Inode Watcher. So basically, what you provide here is a path. And what you get back is a file descriptor referring to an open Inode Watcher. And Inode Watcher is indeed a public file here, as you can see, and it implements the basic Unix file interface, and it is linked to a specific inode. It is weakly linked, so if the inode goes away, then the Inode Watcher does not keep the inode alive, and it doesn't have a strong reference to the inode. But what it does do is it keeps a queue of things that happen to that inode. And at the moment, we remember the last 32 things that we call Inode Watcher events. And basically, there is in the inode, there is a list of watchers. So we have a hash table here of Inode Watchers. So whenever you instantiate an Inode Watcher, it will tell the inode, hey, if something happens to you, let me know. So the Inode Watcher goes in this table here, and whenever something interesting happens to the inode, it will call, on all of its watchers, it will call the appropriate function here. So notify inode event, notify child added, notify child removed. And then internally here, these go and add some kind of Inode Watcher event to the queue that we mentioned. An Inode Watcher event is a very, very simple data structure that at the moment, only has a type and an inode index field. So it's extremely limited, but it does notice things like, hey, a child was added to this directory, or a child was removed from this directory, or the modification time or the metadata on this file was changed somehow. And we use this in the file manager primarily, where it is quite crude. And let me show you an example of it. So you see the file manager is open here, or actually I can even use the desktop. So if I just create a file here called foo, then the reason that it pops up right away without me having to do anything is because the file manager process that hosts the desktop has created an Inode Watcher on the desktop directory. And then the kernel, when we add the foo file here, the kernel will put a child added event into the Inode Watcher queue for that Inode Watch on the desktop. And subsequently, the file manager reads from the Inode Watcher and learns that a child was added. But yeah, so this is where we are today, essentially. And there are a bunch of limitations with this API, right? It's clearly not very rich. Like maybe you learned that a child was added. What was the name of the child? You don't know. Child was removed. Same problem there. You don't know which child was removed. So the end result of this extremely granular information is that we really don't have much choice. When we learn that something changed, we just have to reload everything. And that is quite inefficient, right? Because we can't do incremental updates of graphical interfaces that display file system state. So This has been a long-standing issue in the system. So I am interested to see what SynAc here has come up with. So now that we have some context, we can read the PR. So this PR implements a new style of watching files via Inode Watcher. Previously, Inode Watcher would only be able to watch a single inode at a time, but now Inode Watcher will be able to watch many files at once, receiving events for all of them. A summary of how it currently works. The watch file syscall is removed, and in its place, the create iWatcher, iWatcher addWatch, and iWatcher remove watch calls have been added. Inode Watcher now holds multiple watch descriptors for each file that is being watched. The Inode Watcher file descriptor can be read from to receive events on all watched files. Alternatively, one can read from a specific watch descriptor to receive events only for that file. When the Inode Watcher is closed, all its child watch descriptors are also closed. This PR also adds some utility methods to lexicalpath that may be useful for other things. And finally, core file watcher and subsequently its users have been updated to take advantage of this new API. Okay, yeah, so that's something we didn't talk about. Core file watcher is a convenience class that it's just a C++ API that sits over the, this is, my CLion doesn't know about this. So blocking file watcher and file watcher, these are C++ convenience API on top of the file watch mechanism. So I guess we should have looked at the header, not the implementation. Yeah, so you can create one of these things and then you get a convenient function callback when some event happens. So it's just makes it a bit easier to work with these. So, oh, look at this file watcher event. And then it has a child path here, but where would we get that from, I wonder? Get child path from inode index. Ooh wee. How does that even work? I don't. Get child path from inode. Oh no. Okay. So, okay. Yeah, right. So currently we do have a user space way of getting the child that was added, I suppose, in that we can walk the entire directory and look for a directory entry that has the same inode index as the child inode index that the kernel told us. So that does kind of work. It is racy, but I guess it does work. So it will be much nicer if we can, if the kernel can actually tell us the name and we don't have to go and look at all the files in the directory. Okay. So I guess the, I mean, we can look at, excuse me, we can look at some of these commits here. So the first one is add lexicalpath append and lexicalpath join. So we're adding two new functions to lexical index? What the hell is lexical index? Okay, that's not a thing. So first bug found on the first line of the first commit message. So this is something that really bugs me about GitHub, by the way. There is no way for me to like make a comment about the commit message. If I want to comment on the commit message, I have to just select a line somewhere in the diff and put that comment there. So that's what I end up doing. But I really wish that they wouldn't force you to do that. And I've asked GitHub for this feature, but you never know. Hopefully they would care about it. So typo in commit message, lexical index should be lexicalpath. Okay, and so what do they do? Appends a new path component to a lexical path, and join constructs a new lexical path from one or more components. Sure. SB. I don't love, like, this kind of pointless abbreviations I don't really like. So let's call this builder. And what does it do? It simply takes the, so a lexical path, by the way, I should mention, is it's a helper class that we have in the ACK library, which represents a path string. So it has slash separators. It's a Unix path, and it breaks it into components, so you can find like each directory part, and it also normalizes .. type stuff, so that if you go up and down the directory tree within the same path, it will normalize that. But what it does not do is it does not interact with the kernel in any way to canonicalize the path against the file system. So it's only canonicalized lexically. And it is a very useful class, but I think sometimes people misunderstand it to think that it will actually go and resolve the absolute path of what you give it. But it does not do that. That's why we call it lexical path. It's strictly lexical. Anyway, I guess I would suggest using append. Maybe something like that. Or, I mean, in context, it will look better like that. Okay. And then join. It feels unnecessary to take the string by value here. Can we take the first string by const reference here? And let's call this Wheeler. Okay, so now that we have nitpicked that patch, let's move on. So here is implement multi-watch Inode Watcher, and we're looking at 1200 lines added, almost 300 removed. So let's just peek ahead at the next patch to see if that's something smaller. That's update for the API that was added in the previous patch. Oh, wait, I wasn't looking at that right, by the way. Because this is the whole PR, not the individual patch. So, but it is still very chunky. Okay, so then what was the last change? Add unit to coretimer interval arguments. Right, so this one we can look at independently. This patch adds the ms suffix to the interval arguments in coretimer to make it a little clearer what the interval unit is to others. Yeah, I think that's a great change. An even better change would be if we could encode the fact that these are milliseconds into the type somehow. We don't have anything like stud chrono at the moment, but I do think that in terms of tiers, like the highest tier of information encoding is putting this type of info in the type. If you can't put it in the type, then put it in the name. Yeah, those are clearly nice. Some people like to put it in the comment, and I think that is just obviously inferior to putting it in the name. Like you would put a comment above here saying like, oh, the interval is in milliseconds. Anyway, maybe we should consider updating the m interval as well, since we are doing this. So I will make that note. Since we're doing this, let's also rename m interval to further increase. What do we call this? Further increase. Make this clear. Just make this even clearer. make the class clear internally as well. All right. I think that's nice. Okay, so then, oh, and the very last commit is adding some unit tests. Okay, so let's go and look at the big thing. So what does it do? The patch modifies Inode Watcher to switch to a one watcher, multiple watches architecture. The following changes have been made. Okay, so we read these in the main PR description. The thing that I'm a bit weirded out by is that you could read from a specific watch descriptor to receive events only for that file. That sounds a bit strange, but we'll see, because I don't really know what that means yet. So I think one thing that we should do is check out the branch. So let me just go ahead and add a remote. And then we will check out new Inode Watcher and build that. And that immediately went badly because okay, let's see if we can rebase this on origin master. Just right quick. Okay, I don't know what the issue was, but cleaning and rebuilding seems to have bypassed it. So that's cool. We'll just let that build while we continue looking a little bit. So, clickety-click. So adding limits.h to the kernel is immediately sketchy. Limits.h. Yeah, because this one is strange. I don't know. Should be including limits.h like this. Kernel. Since it belongs to libc. However, this is an API header, so it also needs to be, it will be included both userland and kernel. Perhaps, I mean, why does it even work actually? Limits h. Who includes Inode Watcher event.h? That's what I want to know. The kernel includes it. Okay. Limits.h. I wonder if it's picking up our limits.h or is that coming from somewhere else? Now I'm wondering if we're picking up like limits.h from the toolchain or something. I'm not sure about that. C limits. Well, probably not. That's weird though. Yeah, I'm just gonna put a comment about that because I'm not exactly sure what the solution is. So one thing that you could do, which we sometimes do, is something like if def kernel, then include libc limits h, else if not kernel, something like that. But it is weird because the libc headers should not be in the default include path when you're building in the kernel. So I don't know why this works. I guess that's what weirds me out a little bit. Why does this even work, actually? Yeah. Okay, so then Inode Watcher event is expanded a little bit here, oopsie doopsie. So the type is turned into a bit field for some reason. Okay, so I guess I can sort of see the logic of turning it into a bit field because you could have metadata modified and content modified at the same time, so you could merge those into one event. But something like I mean, some of these are not combinable or whatever, but I guess that's fine. Okay, and then the watch descriptor. So my understanding of the watch descriptor is, so far before having seen them, is that we'll create an Inode watcher, and then we will add individual watches to it, and then it will keep track of all of our watches. In the previous architecture, you had to open a new Inode watcher for everything that you wanted to watch. So if you wanted to watch a directory full of files, then you had to create a new Inode watcher for each file. And now you can create one Inode watcher and then add a bunch of watches to it. So I guess it's similar to iNotify on Linux. Okay, so then the Inode watcher event ends in a variable length array. Presumably the name length determines the length of this array. So that's cool. All right. And what do we have here? So Inode watcher flags. Don't know what those are used for yet, but they look like your typical file descriptor open flags. So here are the new syscalls. So create iWatcher, iWatcher add, iWatcher remove. Sure. iWatcher add takes these parameters: file descriptor, user path, and an event mask. Makes sense. So you're providing the watcher's file descriptor, and then you're telling it which path you care about, and then which events you are interested in. And presumably it will return the unique watch descriptor that was set up. Sure. Okay, and then in ext2 here, we add some hooks here so that we have did modify content. That makes sense. I guess that's where we would then notify any registered watchers about what happened. Did add child now also notifies or includes the name. So we already had this did add child, did remove child, right? Because we already supported those notifications. It's just that we did not provide the name. And now we'll do that, so we have to include it. Makes sense. When the links count goes to 0, did remove self. So that makes me wonder, what is the state of the inode after this happens, it's probably okay. This uncache inode thing is a bit weird because we uncache it and then we do set metadata dirty true. Because if our ref count is 1, this looks weird actually. Decrement link count. So here, if we decrement the link count and we have only one ref on this inode, and the links count reaches 0, that means that nobody in the kernel needs to keep this inode alive except the inode cache, which is responsible for 1 ref count. And the link count on disk is going to 0. So we remove it from the cache, which means that inode cache remove, which means that we remove the last remaining reference to it. So this should delete the inode, like this should invoke the destructor of this inode, but then we are doing stuff to it right after. So I think this is actually a use after free right here. Let's see. I think so. This looks like a use after free. If the ref count reaches 1, only kept alive by the FS's inode cache. It's the FS's inode cache. Inode is a word. Come on. And the links count field goes to 0. We call uncache inode, which will destroy this inode, this ext2fs inode. So both the set metadata dirty call is a UAF, and the code we're adding as well. This was clearly an issue before your changes, but something we should definitely fix regardless. Yeah, okay. So suspicious, but anyway, what's being added here is just that if the links count on the inode reaches 0, then we notify watchers, I assume, that this inode is being removed. Did remove self? Yeah, it's like being removed from disk at this point, or it will be. Although I wonder if it would be more appropriate to do this, or no, when is a good time to do that? Because we have free inode, but that gets called on the file system class, not on the inode. The inode is still live at this point though, so who calls free inode? It's the destructor. Okay, so we're calling this while we are destroying the inode object, but it's still live at this point, and it's still okay. Yeah. That is a bit, it's a little bit like, this code is not entirely straightforward. like the way that we remove inodes. It is confusing. And something that is important to know about inodes is that, and it works this way in all Unix systems, that if you have a file open and you remove it from your terminal, so you rm a file that is open somewhere in a program, the kernel still retains that inode. Like it is kept alive. Even though it does not exist anywhere in the file system anymore, it's still on disk and kept alive because the kernel has a ref counter on the inode, which is separate from the on-disk ref counter called the links count. So the links count is just what you see when you ls usually. So you see here, this is just a number of links, I think. And the reason that directories often have a higher link count is because if you go into, say, ACK here has 4, right? So we go into ACK, ls, and we notice that it has 2 directories, and it also has a third directory here, dot, which refers to self. So all of the links in total are 1 from the reference in the build directory, and then it has 3 references inside of itself. So dot and dot dot in this one and dot dot in that one also refer to this directory. So there's anyway, my point is that there are 2 reference counts for inodes. There's the in-kernel, in-memory reference count, and there's also the on-disk link count. And let's not dig into that too much because we're getting off track, but it is good to be aware that the kernel will keep inodes alive even if all of the on-disk links go away. And we implement the same behavior. That's why we have to look at both the ref count, which is the in-memory ref count, and the links count. Okay, so then we are adding a virtual bool is iWatcher to file.h. So I'm not crazy about iWatcher as a sort of inventing a new term here. I think, or is that like a thing, iWatcher? It's not really a thing. So I'm not crazy about inventing a new name for this. Can we just call it Inode Watcher? Or I should say, not inventing a new name, but inventing a new word. Because it's good to use words that everybody understands to mean something, but I think if you can call something something that makes it more clear what it is, then that's probably preferable in most situations. Now, if iWatcher would be what everybody already called this kind of thing, then we should probably call it that. But since that doesn't appear to be the case, I think using Inode Watcher is probably better. Okay. And then just some helpers for asking a file description if it's an iWatcher, and then getting the internal iWatcher from a file description. Sure. Yeah. So file description already has this type of stuff. If we look at file description, then, for example, if you have a TTY open, you can ask your file description, are you a TTY? And if this thing says yes, you can call TTY and it will cast the file inside the file description to a TTY and give it back to you. And actually, you could even call this thing directly and it will give you null back if it's not a TTY. So we have that for a couple of file types like device, master PTY, and also now apparently iWatcher. Okay. That's probably okay. Right, and then in the inode destructor, we are now adding call to unregister by inode. Okay. That's probably fine. We should maybe look at what's happening in that thing. So for every watcher in Watchers, we call it unregistered by inode, and we give it the identifier of the inode that's being destroyed. And then we look up the identifier, see if we have a watch for it. And oh, this is really weird. Yeah, we should not be invoking. This is like a syscall handler. So user space syscalls go to these sysdollar functions. And they're not really meant to be called from the kernel because they do sort of POSIX compliant error checking and stuff. And I mean, not that there's anything wrong with that in particular, but I think in most cases, the kernel can just more clearly express what it wants to do. And it doesn't have to enter through these POSIX interfaces, right? It doesn't have to restrict itself to using those. So yeah, we should probably fix that up. Anyway, I'm getting ahead of myself. So let's continue reading the patch. Okay, and then in set metadata dirty, we will include the inode identifier when we generate a metadata modified event. Makes sense. Okay, so we did break up. Previously, we only had inode watcher event type modified. Now we have metadata modified and contents modified. So that's neat. Okay, and then in did add child. Okay, this diff here is a bit hard to read because it kind of does diff stuff. But if we look at the new implementations, what does did add child do? It simply iterates over the watchers and creates a child created event for each one with the name that we were provided. Right. So what does notify inode event do? I'm just thinking about the name part here. What do we do with that name? We create an event object, sure. And then append it to the queue. Okay, so event has watch descriptor, presumably, and a string path. Okay. So this one right here, we are taking a string view coming from wherever we were called from did add child. And for every watcher, we're passing a string view to every watcher, and then every watcher will go and turn that string view into a string, which means that everybody will allocate a new string. So I think it would be beneficial if we didn't take the string, the name here as a string view, but rather take it as a string, and then we would only get one conversion from string view to string at the call site. Or even if the call site actually had a string originally, then there would be no conversion. So who's calling did add child? Let's investigate that. ext2 file system after adding a child, sure. And name at this point is it's a string view, sure. But who called add child? It's very possible that we could even have a string all the way through here, because it is probably a string originally. Yeah, so let's take the name as a string instead of a string view. the watcher has to convert it to a string anyway for storage in its event queue. So we can avoid, we can limit ourselves to a single. We can cut down to a single string view to string conversion by hoisting it through the hoisting it up the call chain. And let's see. I think, I mean, I have the same comment here. Okay, and then we are ignoring dot and dot dot. That's probably fine. Please wrap this in, since it spans more than one line. Okay. Did remove self, delete self. Since the generated Inode Watcher event type is of type deleted, perhaps the function should be called did delete self for consistency. Sure, it's always nice to be consistent about things because it just it lowers your cognitive burden while reading the code if things are consistently named. Sure. So I think the child ID name here is kind of, it's mostly implied by context, but let's ignore it. And oh, and here we do have an example of including this libc header in this way instead. So I do wonder why the API header was able to do it, but not this one. Okay. No need for after Inode Watcher. Okay. Yeah, so this is just a helper to instantiate one of these. In the spirit of some recent work that is going on in the kernel, we should probably, while we're doing this, we should also make it handle out of memory conditions. So in the spirit of recent anti-work in the kernel, let's make this return a key result or non-null ref footer to Inode Watcher. And make sure we propagate allocation failures to the caller. Yeah, look at that, ignoring close errors. Typical. Close is one of those annoying things because close can technically fail, but there's so much code that does not try to handle that situation. And look at that. It's already somebody here saying that this feels weird. There does not seem to be a kernel side method of closing foods on a process other than sysclose, it seems. Even so, please add, then maybe we can add something that sysclose And this function can both call. Sysfoo functions are really only meant to be called from the syscall entry point. Okay, so what's going on here? We can't bail here, so if close fails, then we just do nothing. It seems like we could at least debug something if this happens. Yeah, we can at least print something on the debug output. See comment in unregistered inode. So what is this? You're closing an inode watcher. Sure. Wait, why are we calling close? What is going on here? Food to watches. Okay, I want to go and look at what this new syscall actually does. iWatcher add watch. What does it do? So, wait. So it allocates a file descriptor. I don't understand why we need that. So let's see. So iWatcher add watch takes in the parameters, blah, 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 checks that the thing that you're calling it, the file descriptor that you provided is an iWatcher, sure. And then resolve the path that you provided. We check that the file system that the path is in supports watchers, sure. And then we finally allocate a new file descriptor. So I think that this is really weird. Like, why do we need to allocate a file descriptor every time that you add a watch to an open iWatcher, an open Inode watcher? Is that what Linux does? I notify, add watch. A successful call to iNotify add watch returns a unique watch descriptor for this iNotify instance, blah, blah, blah. Okay, so it seems really modeled after this exact API. But I don't think that watch descriptors are file descriptors. Because like if you are out of file descriptors, you would get like em file, right? So, or no, m file, too many open files. And this is not listed as an error code. So I think the watch descriptor should not be a file descriptor, but rather just a unique number within that specific Inode watcher. Because I guess I don't see why you would want to have a file descriptor. So the PR description mentioned that you could read from an individual watch descriptor to get events for only that specific watch descriptor for that specific inode. But I don't necessarily think that's a use case that we care about. So I'm a little bit suspicious of this whole thing. But let's keep on reading through the code. Okay, so now it becomes very muddy here because of the diffing algorithm. So this is the Inode Watcher class. Let's just go and read it in here instead. So Inode Watcher. So what does it have? Internally, Inode Watcher now has foot to watches. I assume that's like actually like the watch descriptor mapped to a watch descriptor, which is an integer mapped to a watch descriptor object. So it does not, it doesn't seem to follow the descriptor versus description terminology of file descriptor being an integer that refers to a file description. But even so, and then we have share own pointers in both directions, or what's even going on here? Inode to watches, or no, these are not. I guess they don't necessarily overlap. Seems like this header is not needed. We can definitely comment that on the bug. Let's see. Is this header actually needed? Yeah. Okay, so let's look at what happens when you call notify inode event. So then we take a lock. Sure, so Inode Watcher has an internal lock. Presumably it's in watch file. It's a parent of Inode Watcher and watch descriptors. Since both of them inherit from file. Okay. So we take a lock to guard the state, sure. Then we have unnecessary white space right here. But it's a bit difficult to see in the diff. Please don't leave extra empty lines after opening a curly brace. Opening a curly brace. Okay. I think if, in a situation like this, by the way, if you are going to make a local reference binding to something for having like a more convenient name for it, if you're gonna dereference it immediately anyway, I think it's okay to dereference here and then give yourself the ability to use the dot operator instead. So that's what I would recommend. I suggest dereferencing. Dereferencing this. Am I not spelling that correctly? Dereferencing. Oh, come on. Add to dictionary. Here. So we can use dot later. Yeah, that's a bit sweeter. Okay. And what is the watcher anyway? Inode to watches. We get an event for an inode, and we take the inode ID that had an event, look it up in the watches set. So I guess that means we can only have one inode identifier, one watch descriptor per inode identifier. I mean, at least that's a limitation that we clearly have here. So it's probably okay. So maybe they do overlap, actually. Anyway. Okay, so we create, if it fits the event mask that we are watching, then we create an event with the watch descriptor here. Yeah, like the more I read about this, the more this feels off. I think it should just be a unique number within the Inode Watcher. Then we don't need the separate class. Okay, so then notify event, what does that do? Puts, oh wait, it puts an event on the watch descriptor queue. Wait, so the watch descriptor has a separate queue. So every watch descriptor has its own queue instead of sharing the queue with the Inode Watcher. So look here. So when we notify Inode event, then this event right here, it goes both on the watch descriptors queue and on the Inode Watchers queue. So there are two events, one in both places. I think, I mean, I still don't understand the use case for this. But I think we should only have one queue in the Inode Watcher. But we'll get to that. I need to keep reading this thing until I can write a good comment about this. Okay, so when you register an inode, which happens, who calls register inode? Wait. Inode Watcher register inode. Why do I not remember what this is? Oh, it's called from the API. Okay, iWatcher AdWatch, sure. Okay, so when you call register inode, you're providing an FD. So that is the file descriptor, the watch descriptor that we have allocated at the process level. Okay. And if we already have that watch descriptor in use, we return eExist. Or if we're already watching this inode, then we return eExist. Yeah, that's a bit sketchy, but okay, fine, whatever. And then, okay, so there is complete overlap. There's just two different ways to refer to the same watch descriptor. All right. Watch descriptor create. And then we register this watcher with the inode. Right. Okay, so we're just also enforcing the idea that the same watcher can't watch the same inode twice, which makes sense. Unregister by file descriptor. Unsigned FUD. It's so weird to see FUDs being taken by unsigned everywhere instead of int, because FUDs are typically int, even though negative values are invalid. Because this is weird in a different way, right? Because like, what if you pass it a value that's larger than int max? FUD to watches. So who calls unregistered by FUD? I guess it's the remove. What's this call? This is iWatch or remove watch. Yeah. Right. So I think this just needs to become. I've said this like 20 times now, but I think this just needs to stop being a file descriptor. But so the remove watch descriptor API does. Wait, watch descriptor won't modify the inode, but we will. And our signature in register inode reflects that. What does that mean? Does that mean that the fact that we're calling unregistered watcher, that's the modification that we're talking about? Unregistered watcher. I mean, because the inode does not have a, it only tracks the watchers attached to it. It doesn't track the watch descriptors attached to it. It only has this guy right here. Yeah. Okay, sure. Unregistered by inode. Okay, so that's like if you have an inode, when does that happen? An inode, when inode is destroyed and we loop through all the watchers and unregister this inode identifier. I mean, that makes sense. That we would tell all the watchers, this inode is about to be destroyed. You should definitely not care about it anymore. It almost feels weird that somebody still has inode pointers at this time. Because these are being destroyed and I guess it's probably okay. Because what we are tracking is we're not keeping pointers, I guess. We're keeping the identifier of the inode. So we don't have stale pointers, we just have about to become stale identifiers. So that's probably okay. Watch descriptor. Watch descriptor has a reference to the inode. That does feel a little bit iffy. Who uses that? Absolute path. It's only used to generate the absolute path. That's the only, wait. No, there was a listing as well. Okay, so there, right. So it's not only used for the path, it's also used to unregister watchers. Sure. That's probably okay. I was just thinking about this absolute path thing. Like, we could hold on to the index, but it is probably nicer to just do this. I just wonder if there's a situation where the inode is no longer valid while we still have a watch descriptor. How would that happen? So you have a watch descriptor and it's being unregistered. So we are here. Unregistered by inode, blah, blah, blah. These get removed. Unregistered by inode. This is called by the inode destructor. So at this point, it's still safe to query the inode for the internal data. But food to watches. But the watch descriptor, this seems risky to have just a const reference to the inode here, because I feel like we're not entirely sure that this will stay valid for the whole lifetime of this watch descriptor, because what if you hold on to a watch descriptor somehow whose inode has disappeared, and then you could call absolute path on this watch descriptor via the proc file system, and you would do a use after free here, I think. So that doesn't seem safe. But I'm also not completely sure about that. But let's make a note of it. Const inode. Are we sure this is safe? It's safe to keep an inode like this. What if the watch descriptor outlooks can be if so, the access in absolute path looks problematic. Oh, didn't write outlive. Oops, oopsie doopsie. Okay, well, let's look into the watch descriptor class to see what that does. Okay, so create, same thing here, does not propagate allocation failure. File description, create. Yeah, there are a ton of places that need to learn how to propagate allocation failure, so it's not the end of the world, actually. I mean, it is something that we need to fix, but work on that has just started, so maybe I shouldn't be too much of a hard ass about that at the moment. Okay. Yeah, so this class is really strange. So it has, because it inherits watch file, it has its own event queue. And then this is sort of a logical child of an inode watcher, which also has an event queue. And events are duplicated in the watcher and watch descriptors, as we mentioned earlier. So you get duplicate events, but because the event queue is a circular queue that's bounded to 32 entries, you will, like, if you don't read from queues, you will eventually start dropping events. But yeah, so let's note this right here. This is where we'll put the big comment about this. I don't think watch descriptors need to be file descriptors. Instead, they can just be a unique integer, any integer that's unique within the Inode Watcher, making them into full-on files, making watch descriptors into full file objects. Seems to unnecessarily complicate a lot of this code. Yeah. The use case of reading them, the way that events are doubly queued, both in Inode Watcher and in watch descriptor, is quite confusing as well. I'm not sure I understand why the per descriptor event queues are useful. What use case, or what use case do they enable that was not possible without them? Yeah, because maybe I'm missing something. I mean, I don't know. It doesn't seem like you would need it. And like if the Linux iNotify doesn't do this, they seem to be doing okay with that. I'm not sure that we need it either. Okay. Okay, what's going on here? Remove watch. Yeah, so then yeah, like this type of thing here where like you remove a watch and that implicitly closes this file descriptor, that's really strange. And none of that will be necessary if we just don't let the watch descriptors be file descriptors. Okay. Can I cancel that selection somehow? No? All right. And then these are the user space wrappers. Sure. I mean, they're just calling the kernel, no big deal. Sure. I guess something I do like to mention at least once to everybody is I encourage you to use your own name and email in copyright headers. It's fun to take credit for things you worked hard on. It's fun to take some credit. Yeah. Okay, so that's that patch. Let's move on to the next one. Take a look here. So now we're in user land, updating the file watcher and its users for the new Inode Watcher. With the new Inode Watcher API, the old style of creating a watcher per inode will no longer work. Therefore, the File Watcher API has been updated to support multiple watches, and its users have also been refactored to the new style. At the moment, all operations done on a blocking File Watcher return result objects. However, this may be changed in the future if it becomes too obnoxious. Yeah, I get that. Okay, sure. So you now instantiate a core file watcher by just calling core file watcher create. Previously, it would provide a path that you want to watch. And then now you call add watch with the path and the type of events that you're interested in. Makes sense. It feels a bit weird that we have to provide inode watcher event type here, a kernel API type, instead of core file watcher having something for us, having something brand labeled, let's say. Yeah. So let's make enum a add to dictionary. Yeah, because since we're interacting with core file watcher here, which is in libcore, I feel like it should take core file watcher : type as well, or something like that, instead of like taking an arbitrary outside kernel type. Okay, and then we have errors being printed to standard error. That's sure. Not equals true. That looks so weird. That looks so weird. Looks so weird. Let me just say if not watch result value. If not equals true. Yeah, like you don't see that a lot. So this is really weird, actually. Like this error message here. Since this is a user facing string, let's try to sound a bit more authoritative. If we can't produce the actual error that occurred, why not though? Can we not? Why can't we port the kernel error code that occurred? Yeah, I think that would be better if we would report the actual error here. Because like if an error happens on your computer and the software says, oh, I can't do that, maybe this is wrong, that doesn't really inspire confidence. So I think it would be better here if we let's just remove that comment and say this instead. It's better if we can work out, like, we need some kind of plumbing, I guess, to make sure the error code gets here. Touching a file to only modify the copyright header. Let's not do that. That seems unnecessary. All right, so now we are in Hack Studio and we're setting up a different file watcher. Sure, couldn't create a file watcher. Deleted files won't be noticed. combine these into a single warn line? Like, why should we hide the error from the error message? That doesn't seem necessary. If we have an error string or an error message, we should probably include it in what we show to the user. Okay. On change core file watcher event. So what is that class? Core file watcher event. File watcher event is this struct right here. So it's a complex type that has constructor and destructor and stuff. So on change now that file watcher event has a string member, we should change this signature to avoid copy construction. File watcher event. Let's pass it by const reference. Yes, I think that's a little bit nicer. Let's look at some others. So I guess we can go and look at the file watcher implementation. Yeah, so these like return bool or string. I think it would be nice if wait, what's actually going on here? So the string case is an error case, isn't it? Add watch. Return string. Yeah, so the string is an error. Also, why does this thing put the class name in the front of the error and everybody else just says add watch? Don't know why that is useful. Prefixed with add watch, like all other errors in this function. And we had the same thing down here for remove watch. Okay, and then here, this also feels like this doesn't feel reliable because we're taking erno, which is global, and we are calling stir error on erno within a list of parameters here. So I don't know. The evaluation order here is not defined, right? So if class name is called before stir error, then class name may end up changing erno because class name returns a string. So we'll do string construction, which may malloc and all kinds of stuff. So stir error, like in this case here, I think it should be okay because nothing else happens on this line, right? But if you have multiple things going on in the same expression like this, or in the same statement here, same call. Also, I think it's not safe to use stir error erno like this, since erno will be clobbered if class name is called before stir error. And we had the same issue here. Right. File watcher base is inherited by blocking file watcher and file watcher. I guess that's why they were doing the class name thing. But it feels weird to it feels weird. Like, why do they need the class name actually? Is it? Oh, it's added only to. It's only added to be the prefix of this one specific error message. Is this added only? This is added only to. Why do we need? Or no. This. Does this have a purpose other than in one error message? Two error messages. Okay. Then let's see some basics here. So we have is watching, should take, should be const qualified. Should be const qualified and take the path. I'll take this string by const reference. Sure. That's all okay. And then we're adding a formatting helper for these, for this thingy, for the type enum. I guess that's okay. It's a bit weird to have this, like to do anything in the case of like an invalid enum value. Is that something that we do elsewhere? Doesn't feel familiar. Maybe it would be nicer to just verify not reached here instead of trying to truck along. Yeah, because if we're in a state where we have like a bad enum value, I don't know, maybe we should just stop the program. Okay, and now we're in libgui, the file system model. What's he doing with the file watcher? So the model has a file watcher. We check if it's already watching the full path. We don't do anything, but if we aren't, then we add it. And then we watch with metadata modified, child created, child deleted, and deleted. Sure. Does anybody use content modified? I guess I should look here. Okay, well, it is being tested. Okay. I was just thinking, like, because if you modify the content of an inode, we will update the modification time of the same inode. So I don't know that content modified is independently useful. Where do we produce this? Notify inode event. Did modify contents. Oh. Yeah, let's make a note of that actually. Since we always update mtime, after writing to an inode, is the content modified actually you will always get a metadata modified anyway, I think. I think, but I'm not 100% sure. Also, maybe that's like not the absolute best place for that comment. We could have also asked the same comment in the kernel. But since I'm not looking at the kernel right now, I just ended up commenting there. Okay. I mean, this file is just kind of full of converting various user space clients of this code. Oh, look, here's another instance of that weird error handling. But this time we're not checking for not equals true, but rather we're checking equals false. Probably already watching. Can we plumb the actual error here instead? Yeah. I mean, it's not user-facing at this point, it's just on the debugger, but it does sound so weird to me that we don't know what the error is. Okay, file system model index. Maybe node. No need for else after return. Okay. And then here is converting a path to a file system model node. This is a bit strange. Why does this return optional pointer? Optional pointer is a really bizarre return type, because what does null pointer mean then? Node for path. Did we have this before? Okay, so system model node feels like is a strange return type. We usually use raw pointers for this sort of thing, and let the null pointer value be the empty value. The optional T case, it's unclear how to interpret a non-empty value with null pointer. Non-empty null pointer. Okay, sure. Okay, so if we fail to create, we just die. Oh, whatever. And same issue here with this thing being passed by value now. Should definitely change that to passing it by const reference. After we change the signature of onChange to pass core file watcher event, or pass by reference, we should remember to also update these to take a reference. just to avoid unnecessarily copying those on every change. Because why not? It's always nice to avoid allocation and stuff. Fix me. Your time is coming, ungranular updates. Yeah, so I know that that's the next big thing that SynAC is working on is like more fine-grained invalidations for GUI item views and stuff. That's very exciting. That's how I ended up on this path right here of working on the Inode Watcher. This is all one big yak shave because we wanted to improve item view invalidation in the GUI. But this is very, very good yak shaving. It's just it's funny how like you start out trying to improve something and it takes you down this ridiculous rabbit hole sometimes. Maybe node release value. What is going on here? Like, so release value is not really, I mean, so what that does is that if you have an optional that has an engaged value in it, and then you can use release value to move the stored value out of the optional and making the optional empty. But if the optional is just storing a primitive type like a node star, releasing it doesn't actually achieve anything. Release value is primarily useful when you are trying to like efficiently move something out of an optional and into some other storage, and like preserving or sort of using move semantics all the way, right? So here, I think it's not really necessary. Instead, it's just simplifying this as something like node is const cast. I mean, if you want to do a const cast, it can do that, but let's dereference it, right? So maybe node value, something like that. Simplifying maybe is not the absolute best word here, but at least we're not changing the state of the optional, which I do like avoiding if you can. I am hyped about this, the ungranular updates. Okay, sure. La. Outer path. Should this take the path by const reference? This should take the path by const reference. Yeah, because we're doing a lookup, so I think we should definitely. All right, I imagine that we should. Is there some reason not to? We move the path into the lexical path in this branch here. So there's one branch where we use a move, and in the other branches we don't use a move. Yeah, so I think that's like, we don't need to, we can just take it by const reference. Also, please omit the parameter name since it's implied by the function name. This is never actually null, we verify, but if this is made a non-null ref putter, then we can't initialize it. Oh, I guess, or wait, what? I mean, okay. Ref putter will internally verify if you do something to it. So I think maybe this comment is a little bit superfluous. This comment is feels a little bit superfluous. Okay, sure. No, that was probably fine. And then what else do we have? Timer interval arguments, sure. And then tests. Right. So just adding a bunch of tests. So I think because I asked, I'm basically asking for quite a large change here, right? Because I think the watch descriptors should not be file descriptors. I think we don't need to look into the tests at this point. Rather, that's something we can do when the API has been changed. So I guess that puts us at the end of this review. So let's wrap it up with a comment here. I'm sure that SynAct will be happy to receive 43 comments. Very cool stuff. The main thing I think we should, I think we need to change. Main issue I see is watch descriptors being file descriptors. I think this is not necessary, and we can simplify this mechanism greatly by turning them into basic unique integers within each watcher instead. Thank you for working on this. Yes, so I think that's the review, and that will be the end of this video. So if you made it this far, then I thank you for watching. I hope that you saw something interesting here today. I really enjoy actually doing this kind of code review video. I think it gives me an opportunity to talk about things in much greater depth than I do while I'm programming, because then I'm always trying to get to the next step, and here there's like a more natural space to just elucidate or elaborate on things, right? So yeah, I hope you found it interesting. Thank you very much for hanging out, and I will see you next time. Bye.